Let's look at applying the VSEPR theory to a molecule. The question on this slide is, what molecular geometry will capital H, subscript 2, capital C, capital O have? This is an organic molecule known as formaldehyde. Carbon is the central atom. The first step to applying the VSEPR theory is to draw the Lewis dot structure. Pause the video and draw the Lewis dot structure for formaldehyde. Let's see what we get for the Lewis dot structure of formaldehyde. There is one carbon atom in the molecular formula, and carbon has 4 valence electrons. There are 2 hydrogen atoms in the molecular formula, and each hydrogen has 1 valence electron for a total of 2 valence electrons from the hydrogen. There is 1 oxygen atom in the molecular formula, and oxygen has 6 valence electrons. There is a total of 12 valence electrons to work with. We are told that carbon is the central atom, and when we draw a single bond between carbon and each outer atom, oxygen and the 2 hydrogens, we use 6 electrons and have 6 electrons left to distribute as lone pairs. When I distribute these 6 electrons on oxygen as lone pairs, we see that oxygen does fulfill the octet rule, but carbon does not. Carbon only has 2, 4, 6 electrons. Thus, I have to take a lone pair from oxygen and share it with the carbon to form a double bond. The correct Lewis dot structure for formaldehyde has a double bond between carbon and oxygen and a single bond to each hydrogen. Now that we have a Lewis dot structure, we can see that there are 3 outer atoms and no lone pairs on the central atom. When we look at our molecular geometry table, we see that 3 charged clouds with 3 outer atoms and no lone pairs has a molecular shape of trigonoplanar and bond angles of 120 degrees. Don't be fooled by the Lewis dot structure. We tend to draw bond angles as multiples of 90 degrees, which will not be correct for any of our structures except possibly linear molecules. So these bonds are drawn at 90-degree angles, but in actuality they're 120.